For our proofs, this first one, again, I will really encourage you to pause me, try to get through as much as possible, see where you're getting stuck, and try to figure out how to fix that. All right. So for the easy part, no one should miss the beginnings. So the given statements, those always come first. So you can just say M is parallel to N. And again, you can make it 2 steps if you want to. S is parallel to T. It doesn't matter. You can make it all 1 step if you want for the givens. Okay, you want to see where you're trying to work. The picture's over here, by the way. So M is parallel to N, and then S is parallel to T. And then we're trying to get from 5 to 6. We're trying to get angle 5 equal to angle 6. Okay, so we did one similar to this on Friday. So what you want to do for your next step is you want to try to find something that 5 is congruent to. Okay, the reason why I'm starting with 5 is because 5 came first. That's it. Okay, so since 5 came first, I'm either going to set it equal to 2 or 10, or I could set it equal to 16 or 15. It really doesn't matter which way you want to go. You can go any of those 4 routes. They are all perfectly fine. You could even find 3 and 13 if you want to use same side interiors. That's fine too. Okay, so I'm just going to stick with 5 and I'll go with 2. Okay, so that's where I'm going to start. So 5 and 2. And you have to give the reason why. So the reason why 5 and 2 are congruent to each other, they are both in the same position, top right, top right. So both of these are corresponding. Okay, next, I'm trying to work my way to get 5 and 6. So I need to do something with 2 and 6. So I can say 2 and 6 are equal. And the reason why 2 and 6 are equal is because they are both inside S and T. So they're inside these parallel lines. 2 is on the top, 6 is on the bottom. So these are alternate interiors. Okay, now I can get to my last step with 5 and 6, because now I can say 5 and 6 are equal. If I leave these out, do not have to cross those out in the proof. I'm just doing that for my visual learners. So I'm left with angle 5 is congruent to angle 6. So the reason why 5 and 6 are congruent is because these got crossed out. So cross out the repeated. That is your transitive property of congruence. Okay? It's going to be very similar in number 2. So I encourage you to pause and see if you can get all of those steps. Easiest is step 1. You can make them 2 steps if you want, but it's the same ones. M is parallel to N. S is parallel to T. These are both given. Okay? So you always want to start and look where you're trying to get. We're trying to get 1 and 3 together. So I'm going to start with 1. And I'm going to find something that 1 is equal to. So it either needs to be over here or over here, because those are the ones that are attached to the same line. Okay, I can't do these 2 because they're attached to all 4 lines. 3 is attached to N and S, and then 1 is attached to T and M. That's why we can't put those together. They don't have a relationship. Okay, so you could have done 1 and 7 as corresponding. You could have done 1 and 12 as alternate exteriors. You could have done, 1 and 4 as alternate exteriors, or 1 and 8 as corresponding. Any one of those work. Those would probably be the easiest. So I'm going to stick with, I'm going to do 1 and 4. So 1 and 4 are alternate exteriors. Okay. Working my way to get to 3. So I can do 4 and 3 together. So now 4 and 3 are congruent. The reason why 4 and 3 are congruent is they are alternate interiors. So they're both inside of T and S. 4 is on the bottom, 3 is on the top. Okay, that's it. All right, I got 5 for you today. So number 3 is next. These ones that go with this picture over here, same picture pretty much. This time they give you degrees. Okay, so you're just trying to work your way over. Okay, so first one, always given. It should say the measure of angle 8. So we're at 8, and we are trying to get to 7. And it should also be, honestly, if we're being technical here, it should also tell you that the lines are parallel. So just like in that first one, it should be in the given that your lines are parallel like this. Okay. So I've got 8 right here as 125, trying to get to 7. It's basically the same exact thing. So you're just using numbers instead of the angle signs. So you have options. Your options could be angle 8 and angle 1 are corresponding. Angle 8 and angle 13, alternate interiors. Angle 8 and angle 3 corresponding, or angle 8 and angle 9 are alternate exteriors. So it doesn't matter. So here's what you can say in number 2. I'm going to say angle 8 and angle 9. So those are alternate exteriors. Okay. And then what else I can say is I can say that now that I'm at angle 9 and angle 7, they also have a relationship of alternate exteriors. I can't fit it. Okay, so those are alternate exteriors as well. So now what you can do is we can say that angle 9, so right here, if I cross out the repeated here, angle 9 is going to be 125 degrees. Okay, and the way I got that was just either cross out the repeated, so you could have said transitive of equality, or we plugged in 125 instead of the measure of angle 8, which would be substitution. So again, either one works. You can either say transitive or you can say substitution. Okay. Then finally, for step 5, now I can, remember I'm trying to get to the proof part. I want it to be that. So in this one, I can finally say measure of angle 7 is 125. And that again comes from here. So you can either cross out the repeated. It's going to be the same thing as step 4. You can either cross out the repeated or you're plugging in angle 7 for angle 9. So this is, again, either transitive or substitution, either one. Okay, so a little bit of, like, you can't just assume, you have to actually show that step 4. I know that a lot of people might want to skip that step 4, but you do have to put that in there. Okay, so you guys try number 4, pause me. All right. So in step 4, given always goes first. Okay, there's my given. So I have angle 16, and I'm trying to make my way over to angle 1 and figure out what its measurement is. So again, bunch of different ways to start it. 16 and 11 or 16 and 6. 16 and 11 are alternate exteriors. 16 and 6 are corresponding. 16 and 14 are corresponding. Or 16 and 5 are alternate interiors. Doesn't matter which one you want to do. Makes no difference. So I'm just going to use 16 and 5. Okay, so 16 and 5, those are alternate interiors. Okay, so then what you can do is you can jump right to the actual measurement if you want. Like over here, I went from angle to angle and then to the measurement. The order, there might be different orders the way you do things. So if it got a little confusing over here, then I'll do it a different way on this one. So in this one, I can say that the measure of angle 5 is also 68, because what I did was cross out the repeated or substituted the 68 in for the measure of angle 16. So again, it's either going to be transitive or substitution. Somewhere, so you might have a mixed up 3 and 4 step, but somewhere in there you got to add something like that. Okay, so right now I'm with 5 and 1, but if you notice 5 and 1, they don't have a relationship. So I got to get another step in there. So to get another step in there, what I can do is I can put 5 and 2 equal to each other. So what that's going to do Those are top right, those are both corresponding. Okay, and then we also have to establish what the measure of angle 2 is. So again, crossing out the repeated, the measure of angle 2 is 68 degrees. That's again transitive or substitution. Okay, so now we're getting somewhere, because now 1 and 2, they have a relationship. They are not equal to each other. They are side by side, and they make a straight line. Okay, so what that means is I'm going to say the measure of angle 1 plus the measure of angle 2 are going to give me a 180, because they make a straight line. Okay, my reasons for that, they are a linear pair. They make a straight line. Okay, you could have also used 13. It might have been easier maybe to use 13. You could have said 5 and 13 add up to 180 because they're same side interiors. And then 1 and 13 are equal because they're vertical. So some of these have a bunch of steps in them. This one is a little longer. That's why I saved these evil ones for today. Okay, so in this case, what I'm going to do in step 7 is we know that measure of angle 2 equals 68. So I'm going to put 68 right here. Okay, so what I did was this one, I definitely plugged that in. So I knew that 2 was 68, and I plugged it in for the measure of angle 2. So this one is definitely substitution. And then what I can do is I can say the measure of angle 1 equals, and what I'm going to do is subtract the 68 from the 180. So the measure of angle 1 is going to equal 112, which is what I wanted. Okay, and then the way I got that was subtracting 68 from both sides. So that is subtraction property of equality. Not easy. I totally understand that that is not easy. There are a million steps, and you might have skipped a few in there. So that's why you need a lot of practice with these. Okay, one more down at the bottom. This is not nearly as difficult as that last one. That last one was a tough one. So this one right here, this is more of an algebraic one. Remember when I did the algebraic ones, that's just when you're solving a problem and telling me why. So that right here, that's step 1. I'm not going to rewrite it. So that's given. Okay. Next thing you would do out of this, the first thing you would do, in my opinion, would be to distribute. So in step 2, I've got my 2m plus 5. And then I'm going to have 5m minus 35. And then don't forget your minus 3m. Okay, so step 2, all I did was distribute. That's the distributive property. Okay. The next thing you would do, you might do it a different way. What I would do is I would combine like terms right here. So 3m minus 5m minus 3m is 2m. Okay, so all I did was I combined like terms. When you combine like terms like that, you're plugging in the answer instead of doing 5m minus 3m. So this is called substitution. And then from here, it shouldn't be too difficult because you're just going to minus 2m from both sides. So if I minus 2m from both sides, what happens is they both cross out. You get nothing. So I'm left with 5 equals negative 35. And that was, we subtracted from both sides. So subtraction property of equality. And then finally, it says, look what it says, prove m has no solution. Well, this is false. So since that is false, if it's true, that actually means there are infinite solutions. So if it said something like 5 equals 5, that means it's always true. 5 does equal 5. So that's an infinite amount of solutions. If it's not true, like this, 5 does not equal 35, then you're just going to say, this is where you say m has no solutions. Okay, and there's not really a reason for that. We figured it out up here and we proved it up here pretty much. Okay,